Okay, so in this make-believe problem, we have ourselves what looks to be a table on a graphing calculator, and we answer a bunch of questions. Now let's take a good visual of what we have. All right, t is very small, and it works its way up. H of t is very big and works its way down. So without knowing everything, this is basically the picture that we have. Okay, there's some curves probably somewhere built in there, but all I know is on the very left to the very right, we go up, down, and that pattern doesn't seem to stop. So find h of 999. Well, it's right there. Negative 478. Don't overthink it. Find the limit as t approaches infinity. As t gets larger, that number is getting smaller, 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 faster, so we can assume that number is just going to keep dropping down to negative infinity, like so. As t increases without bound, the h of t, now increases without bound is just fancy talk for the limit as t approaches infinity of h of t, which we already know what's going to happen. But what's going to happen as it increases without bound, the h of t, I don't know how it wants us to word this, but I stole this problem from the internet, so I'm just going to word it the way I want. We'll say decreases, because we already know it's negative infinity, so we'll just say it decreases and continue to use words. Find the y-intercept. The y-intercept exists where x is 0, or in this case t, and when t is 0, you're at 32. Find the limit as t approaches negative infinity. That means as we move to the left, my picture is moving up. The number is getting much, much, much larger as t gets much, much, much smaller, so we will say positive infinity. And as t decreases without bound, which is the same thing as what E is saying, the h of t increases, and that's the way we will word it. So we can say consistent with C. And there you go.